I'm Jim Wild, and I'm a space scientist at Lancaster University, and I study the links between the Sun and the space environment around the Earth, in particular the electromagnetic links. So the work I'm doing at the moment is really getting interested in space weather, and this is the phenomena of how solar activity can send disruptions into the interplanetary environment, and these can come towards the Earth, and when they arrive at the Earth, they can interact with the Earth's magnetic field and generate lots of beautiful natural effects like the aurora borealis, but also they can generate some disturbances for the technology and the resources and the infrastructure that modern day civilization depends on. And in particular, that would be things like power grids, so disruptions to the Earth's magnetic field, so the gentle kicking the Earth's magnetic field gets from coronal mass ejections launched from the Sun, can drive electrical currents through the surface of the Earth, which prefer to travel through the conducting wires of a power grid, and can actually damage the transformers or affect voltage stability in the grid. So these things which cause, these disturbances which cause beautiful natural effects like the aurora borealis can have also a slightly more sinister side for modern technology. And it's not just technology on the ground, the power systems are a good example, but also above the ground, so avionics in aircraft and communications with aircraft, and also satellite operations can be affected by changes in the space environment, by changes and disturbances in the upper atmosphere, by increases in the severity of the radiation environment around the Earth. So all of these things are really important as we go into a society which is absolutely dependent on high-tech systems on the Earth and above the Earth.
My name's Lucy Green, and I work at the Mullard Space Science Laboratory, which is a department of UCL, and I study solar activity. People are naturally interested in learning about the Sun. It's extremely visual, very beautiful object. But when it comes to talking about space weather and how the Sun impacts us here on the Earth, there are definitely challenges in that communication. For example, we're dealing with a hugely complex topic here. We want to trace the energy flow from the Sun through space to the Earth's magnetic field and then down through the atmosphere into the surface, and that involves a huge number of research areas and a lot of joining up the dots. So getting different scientists together is key to pushing that one. Another challenge in communicating the science of space weather is that quite often people maybe over-egg the issue, and that could potentially lead to people worrying excessively about what's going to happen. So the kind of end-of-the-world scenario is quite an appealing one. You know, these huge eruptions of magnetic field and charged particles coming from the Sun, slamming into the Earth's magnetic field, causes a huge cascade of events to take place. But we are looking into the science of this, and we are working towards mitigating the risks. So even though it sounds very dramatic and people might panic, there is no need for that panic, and that's something that we definitely have to understand when we're communicating space weather.